really mean it when I say it. What you should be doing when you're practicing maths and doing questions is actually having your log table right beside you. So when you're going through questions, make sure you know what formulas do I have, what formulas might I need, whereabouts in the log table is it. Get used to using it. A lot of people might go into exam, have not used their log table in months, and will get very stressed out, flicking to and from test log table to test log table, okay? So let's jump straight into the question, guys. We're looking to find the distance between R and S. So the distance between R and S, okay? So the distance between R and S. Some of you might recognize this. This is a bit similar to trigonometry, okay? Did this yesterday. But give that your best go, guys, okay? And when you're done, just text me your answer, okay? Just text me your answer when you're done. And I'm going to be going to and from our log tables, showing you how to use the formulas as well, okay? So just text me your answer when you're done, okay? Brilliant, getting some answers in already, but take your time, guys. Don't let me rush you. Okay? You're way better getting a question done right than getting it done fast. You get no marks in your test if you get something done in 30 seconds. Okay? It's the same amount of time. Just you make sure you get it done in your own time. Okay? Really, really good, guys. Okay? Super, getting loads of answers in now, okay? Yeah, loads of answers in, guys. Keep them coming, okay? Really good. Okay, this might remind us of something we were doing yesterday, Pythagoras' theorem. Okay, see that's a right angle triangle stuff? So have a good think about that, okay? Someone's giving me coordinates. What we're looking for is a length, okay? So we're looking for one number. Shouldn't be a coordinate, should be one number, okay? Yeah, perfect. Okay, loads of answers coming in. Keep them coming, guys. I'll give you about a minute more to do that one. Now I'm going to explain it, okay? I'm going to be calling on someone to give me a hand. Yeah, really good. Okay, so let's go through this question, guys. I'm going to call on someone. Let's see, Dermot, do you want to give me a hand?
Yeah.
Super, thank you so much. So, Dermot, do you want to take us through how you got this question?
I labeled the coordinates x1, y1, and x2, y2.
So which coordinates were you labeling there?
R and S.
Super. So we've taken R, which is 1, 2, and you're going to label it x1 and y1.
Yeah.
Super. X1, y1.
And
And then
then,
for S, you've done the same.
yeah,
And what did you label it this time?
x2, y2.
Perfect. Yeah, really good.
And then I just subbed it into the formula.
Yep. And guys, our formula is x2 minus x1 squared plus y2 minus y1 squared, okay? And we're square rooting all of that, guys, okay? We squared all of that. So we squared all of that, right? And then what did you get, Dermot?
I got 5 as my answer.
Super. So let's go through this, just the maths on that. So we can have a look. 5 minus 1 equals 4. So we're going to get 4 squared. And 5 minus 2 equals 3. So we get 3 squared. We add them together and we square root it. When we do that, we get 16 plus 9 square root. And 16 plus 9 is obviously 25. And we know that the square root of 25 is 5. Well done, Dermot. Very good work.
Thank you.
Okay, so that's a real good warm-up, guys. A lot of people got that answer. Well done. Some people are asking, can I use the rise over run formula? So Kiva, the rise over run formula refers to calculating the gradient of a slope, okay? Not the length of something. And Irene has asked which log table formula. So that's a really good question, Irene. So the log table formula, if we were to go to our log tables, we're looking at length of PQ. I see this big long one here. We've got the square root of x1 minus x2 minus x1 squared plus y2 minus y1 squared. So that one there is what we're looking at, okay? So slopes are one of the most important things we're going to learn in coordinate geometry, and it takes up a large portion of the questions we're actually asked, okay? So it's really important that we know them inside out. So what is a slope, guys? All right. What do you think a slope is? If people want to text me what they think a slope is when they hear that term in coordinate geometry, what do you think it is? If you want to just shoot me a text and let me know, what do you think when you hear it? Yeah, okay, good. Getting some answers in. Okay, brilliant. Yeah, and got some really correct answers. Yeah. Some people are saying rise over run. Yeah, maths hill, that's a good way to describe it. Yeah, how steep it is, rise over run. Perfect. Really, really good work. Incline, decline, that's exactly what we're thinking. Yeah, really, really good. Steepness of a line is absolutely correct. That's exactly what we're looking for, guys. It's how steep is that line, and the number associated with the slope. So the gradient tells us how steep a line is. So we think about this is not a steep line. This is a very steep line, and let's say this is a negative slope, and this is a very negative slope. Okay. So that's really, really good. People seem to have a good understanding of that. And how we calculate that is we take the rise over run. So what I mean when I say rise over run, we're looking how far did the line travel upwards and how far did the line travel across. And we divide how much it traveled upwards, so it's rise, divided by the run. And in this case, in this example, we get 3 over 4, guys. So we divide how far did it go across. We divide how far it went up by how far it went across, okay? So we have a few different types of lines, okay? We've parallel and we've perpendicular lines. Two lines are shown in the diagram below, okay? And both of these slopes have the same, both of these lines have the same slope, which is a half, okay? These lines are parallel. Now, what does parallel mean, guys? If you want to text me what you think parallel is, I'm going to go through the perpendicular example, but text me what you think parallel means, okay? Yeah, getting some good answers in. Yeah, really, really good. Someone's got some brilliant examples there. Yeah. Few people are getting wee bit confused with perpendicular, but really good. Brilliant. Yes, guys. The main thing about parallel lines, which people seem to have gotten absolutely correctly, is that they never meet. If I were to extend these lines on for 1,000,000 miles, these lines will never meet, okay? They never meet. Really, really good. That's what parallel is. And when they have the same slope, they're never going to meet, okay? Now, few people got confused between parallel and perpendicular. Well, what's the difference? Perpendicular lines are ones which meet at a right angle. So remember we went through right angles yesterday? These ones meet at a right angle, just like that. Okay? And how do we know the two lines are perpendicular to each other? That's if they have the negative inverse. Okay? So if they are the negative inverse of each other, we say that the two lines we say that the two lines are perpendicular if they are negative inverse slopes of each other. So if one slope is a half, the other slope is minus 2 over 1. We flip that fraction, or just minus 2. Okay, so flip it, take the reciprocal and multiply it by minus 1, and you get a perpendicular slope, we say, okay? Yeah, really, really good work, guys, okay? To get the perpendicular slope, as I said, we just flip it upside down and we change the sign. So imagine we had the slope of one line is 2 over 3, and we're looking to find the slope of a line which is perpendicular to this one. But we flip it over and we times it by minus 1. We flip it over and times it by minus 1. So if 2/3 is the slope of one line, the perpendicular slope is minus 3 over 2. I want you guys to give this a go. So if I had a line L1 that has a slope of 3 over 8, I want you to find the slope of another line, L2, if it's parallel to L1, and I want you to find the slope of a third line, L3, if it's perpendicular to this first line. Okay? Let's give that one a go, guys. And send me your answers, okay? Just send me your answers when you're done. Really, really good work. We're all doing exceptionally well today. Everyone's super engaged. Really appreciate everyone answering all my questions and stuff. So guys, give us the answer for the first one first, and then the second one. So find the slope of the parallel line, and then find the slope of the perpendicular line. Yeah, good. Getting some correct answers in. Yeah, really good. So a few people say they're a bit confused. That's okay. So guys, think about it this way, okay? How do I know that parallel lines have the same slope? Well, let me draw two lines, okay? Imagine these lines are parallel. We know that they have the same slope because if they didn't have the same slope, even if they had a slightly different slope, they would meet at some point. It's only lines which sort of walk like this, completely in the same direction to each other, that we know are parallel. So they have the same slope or the same gradient, okay? And a perpendicular line, as I said, they're traveling in completely opposite directions. So one's positive, one's negative, one's at a certain degree, one's at the opposite degree. Hence, we flip the slope over and we times it by -1. And that gives us our nice right angle, okay? That's how we get that, guys. Keep the answers coming in. Really good. Yeah, really good. Good people are specifying what are the differences. Remember, the second answer is going to be negative, guys. That's something a lot of people are forgetting. A lot of people are forgetting that we need to get that -1 going as well, okay? Okay, really, really good. Yeah, -8/3, brilliant. Okay, so the answer to the first one, guys, as a lot of you have correctly said, was just 3/8. If two lines are parallel, they have the same slope. Now, the second question asks, what's the line that's perpendicular to L1? And that's -8/3. Okay, so the first one's 3/8, and next one's -8/3. Okay, so one parallel, one perpendicular. Just like that, okay? Now, a central part of coordinate geometry on the line is finding the equation of the line. This is a really, really common question, and it's one that goes for a lot of marks, okay? We need two things. We need a point and we need a slope. That's how we form the equation of the line. There are two ways we can go about this, guys, and it really is just personal preference. One is in our log tables, and that's y minus y1 equals mx minus x1. We use this when we know a point on the line. So if you only know one point on the line and you know the gradient, you can work this out. But using this formula on the right-hand side, we use this one when we know where the line crosses the y-axis, okay? So I'm going to show you examples of those guys, right? So first of all, we're going to do this question. And this is really to do with our formulas. So in this diagram here, we've got PQ and we've got QR. The coordinates of the points are 4, 2. I'm going to label them for you just to make it a little bit clear. So the point P is at 4, 2. Point Q is at 8, 5. And the point R is 2, 11. And then the first question asked, find this slope. So find the slope from here to here, okay? And what we're going to do is rise over run to get that. So remember, use your log tables. Okay, and we're doing rise over run. So how much did it rise? How much did it run? Okay. Okay, so we're just looking at slope as we go from P to Q. So rise over run. How much did the vertical increase? How much did the horizontal increase? Divide them by each other. Okay, guys. So please send me your answers when you've worked that out, okay? A lot of people are sending me some really good answers, but just keep sending them on, okay? Brilliant work. I'm going to be calling on someone to help me with this one, okay? Really, really good. Yep, getting some really good answers in. Perfect, guys. Take your time. Don't let me rush you, okay? Okay, really good work, guys. Okay, so I'm going to be calling on someone in about a minute to help me out with this one. Please get your answers in before then. If someone's asked, how do I do rise over run? I'm confused. So what I want you to do is subtract the x value of q, take away the p value of q of p from that, and do the same with the y values. Okay, and then you want to divide them by each other. So find the difference between the y values and divide that by the difference in the x values between the points p and q, okay? Getting some really, really good answers in, guys. That's brilliant. Okay, so I'm going to call on someone to give me a hand with this one. I've Davin McIsland. Can you hear me okay?
Yeah, my name's Sive. I'm just on my mum's account.
Oh, yeah, sorry, no problem at all.
Oh yeah, no worries. So I started off by writing the formula m equals y2 minus y1,
Brilliant.
and then over x2 minus x1.
Yeah, if we just pause you there, you're absolutely correct. Really well done. Just to make that clear for everyone, this one's in our log tables, but y2 and y1 are going to refer to the points in P and Q. Yeah, go on ahead.
And then I subbed it in, so 5 minus 2
Yeah.
over 8 minus 4.
Yeah, and just point out, guys, they're coming from our points. Okay? Yeah, great. And then we obviously get 3 over 4.
Over
And that was your
4.
answer, yeah?
Yeah, and then I
Absolutely.
just went further and it was 0.75.
Yep, sure. So you can write it as either. No problem at all. You won't lose marks for writing it as decimal or fraction. Don't worry at all. I'm really, really good. Absolutely brilliant work. Well done.
Thank you.
Super. Okay, so that's what we end up getting, guys. That's our final answer and brilliantly explained there. Really, really good. And our exam technique was absolutely perfect there as well. Writing out our formula, subbing in our points, then doing our calculations. That's the order in which we want to do things to maximize our method marks, even if we get the question wrong. So really, really good, okay? Now we're looking to find the equation of the line PQ. Now I'm going to give you all the information you need to do this, okay? M equals 3 over 4. And a point on the line was, let's see, point on the line was 4, 2. Okay, I'm going to write out the formula, which is y minus y1 equals mx minus x1. Okay, so sub in your values for x1 and y1 and sub in your values for m, expand your brackets, and now notice how it's asked, give your answer in the form ax with by plus c, so move everything to one side, okay? Really, really good work, guys. That should take us maybe 2 minutes or so. So take your time with that question, sub in all your values correctly. Remember to pay very close attention to the signs and the expansion of the brackets. But really, really excellent work from everyone so far. Okay, really good. And send me on your answers when you get that, guys, okay? I know it's a big long thing to type out in the chat. Or maybe send me a thumbs up when you get your answer, okay? Whichever you prefer, okay? Take your time. Yeah, we've got some people sending the answers. Really good. Thank you, guys. Much appreciated. Brilliant work. Morgan, I'm not totally sure what you're asking me. If you want me to clarify a bit, I'm not a million percent sure. Are you talking about m when you talk about the fraction there? So remember that we just expand that fraction into our bracket, okay? Okay, getting some good answers in. Really good. Okay, really, really good, guys. Okay, take your time with that. Don't let me rush you, as I said. You're much better at getting a question right than a question fast. Okay, a lot of people think rushing ahead is really good, but, you know, maths is a marathon, not a sprint, I would say. Okay. Brilliant work from everyone sending me answers. Really good. Yeah, really good answers still coming in. Take your time with this one, guys. Really important to pay very close attention to the signs. I can see a lot of people are sort of making a few wee silly mistakes with those, okay? Okay, really, really good. Gonna give you a minute or two more on that. Don't worry, I'm gonna be going through this really slowly at the end, okay? Morgan, we multiply each term in the bracket by the fraction itself, okay? So we multiply everything by 3/4. We don't split up our fraction when we're multiplying like that, okay? Hope that makes sense. All right. One more minute or so, guys, right? We're gonna get through loads of questions today, but just give it your best go, all right? Okay, really, really good. That's okay, no problem, Morgan. You'll be sent the recording of the meeting, okay? Okay, so let's go through this one really, really slowly, okay? I'm gonna get someone to help me with this one. Let's see. Gonna go for, yeah, let's see. I'm gonna go for Orla McGrath. Orla, can you hear me okay?
Yeah, I can hear you.
Super. Orla, could you give me your hand with this question?
Yeah.
Thank you so much. Really appreciate
I
that.
put 4 as x1 and 2 as y1.
Brilliant.
So that is subbed into the formula. So I got y minus 2, which is equal to 3/4 x minus 4.
Hold on, you're absolutely right, Orla. Just give me a minute to catch up with you. You're absolutely right. Okay. So we've written out a formula, we've subbed in our values, and what's our next step after this now? We're expanding, is it?
Yeah, and then I'm bringing the 4 over to the y.
You bring the 4 over directly from here?
No, from the fraction.
So what way are you doing this order? Are you expanding your brackets first, or what is it?
I'm separating the slope, so I'm bringing the 4
Yeah.
over the equal sign to the y.
Okay. And what's that becoming?
It's becoming minus 4.
Okay. So when we're multiplying fractions like this, right? We need to expand into our bracket this fraction, right? Like multiply it like we would any normal number. So what we end up getting is y minus 2 equals 3/4x minus 3. Does that make sense, Orla?
Yeah.
Because if you multiply 3/4 by 4, we're going to end up getting minus 3, okay? I totally understand what you're doing with moving it over the equal sign, but we're going to do that in this next step, right? So what we now end up getting is we move our minus 3 across, and that gives us y minus plus 1, because we move our minus 3 across to give us plus 3, and that's going to be equal to 3/4x. But we know the format which we need this in. We need it all to be on one side, and we need each of these to be integers. So we move our 3/4x across, so we get y minus 3/4x plus 1, and I multiply everything by 4 to get rid of my fraction. So I get 4y minus 3x plus 4 equals 0. I'll write that out bigger, guys. Apologies. Screen got to be a bit cluttered there. But does that make sense now, Orla? Okay, I hope it does. So guys, we expand that fraction into our brackets first, and I move everything across, and our final answer ends up being 4y minus 3x plus 4 equals 0. So well done, everyone who got that. Okay, a lot of people managed to get that. So a lot of people have said, can I split up the fraction by multiplying the left-hand side by the denominator? You can absolutely do that. And let's go quickly through what we would get for that, right? Because you would end up getting the same answer. So imagine if we were to do that. So we're looking at 3 over 4 x minus x1, which is 4, equals y minus y1, which is 2, right? So what if we multiply all this by 4? What we end up getting is 4y minus 8 equals 3 times x minus 4, right? Then what we end up getting is, I'll rub this out. So you're absolutely right. This is a method we can use. We then have to expand our brackets. So we end up getting 4y minus 8 equals 3x minus 12. When I bring my minus 12 across, it becomes plus 12. When I bring my 3x across, it becomes minus 3x. So I get 4y minus 3x plus 4 equals 0. So you'll notice that's the same answer, guys. You get there the same way. Okay, does that make sense? Ah, right. Or I thought that's what you were doing. Don't worry. I thought that's what you were doing as well. It's my fault for maybe jumping in and going to the next thing. It's confusing because there's 2 4s there. Well done. I knew because you got the right answer, so I was a bit confused, but well done, okay? Really good. Yeah, so guys, it absolutely does have to be in this format. And this is the format it's in. Sorry, you're right. We need to rejig this slightly. So we just need to move our x term across. So it ends up being minus 3x, was it plus 4y plus 4 equals 0. But I don't think you would lose any marks if you had the x and the y in different places, okay? It's mostly just having everything on one side, okay? So now for this next one, what we're looking to find out is how do we show that a point is on a line? So how do you show that a point is on a line? Well, let's see this, okay? So what I want you guys to do is, we're told the line M is 2x plus 3y plus 1 equals 0. We're told it's parallel to the line. But the first thing we're asked is verify that the point minus 2, 1 is on M. Now guys, this is super simple. All I want you to do is substitute in minus 2 and plus 1 into the relevant spots. So where you see 2x plus 3y plus 1 is our equation. I want you to substitute in your values for x and y and tell me what you get. Okay, just text me what you get. You should get an equation which makes sense. That's what we're looking for. Okay, and that'll become clear. But substitute in your values for x and y and tell me what the left-hand side of the equation is going to be equal to. Bingo. Yep, really good. Some answers coming in. Well done. Ariadna, very good. Thank you, Ross, as well. Perfect. Yeah, some people getting some really good answers. Really, really good. Super. Okay, really, really good. Brilliant. Just one more minute or so, guys. And guys, just a reminder, at the end of the lesson here, we're going to be sending out a wee test, just like we've done the past 2 days. And again, it's super, super appreciated if you guys were to fill that out, okay? Really good. Yep, a lot of really good ones. Some perfect answers here, guys. I'm going to go through this one just as a quick example, okay? So I take my minus 2, I substitute that in as x. I take my plus 1, substitute that in as 3. So let's look. I have minus 4, plus 3, plus 1, which just gives me 0. Okay? Which tells me 0 equals 0. This is what we're looking for. If you were to substitute these values in, guys, and you get a point that's like 3 equals 0, if you get to this point, you should really be questioning yourself. You should be going, does 3 equal 0? Maybe I've done something wrong here. So then you need to go back and check your substitutions, okay? What we want is to prove that the left-hand side is equal to the right-hand side. So that's what we've done on that question, okay? Now we're going to move on to the circle. Okay. So now we're moving on to the circle. People sometimes find this a wee bit more difficult. But remember, our log tables has all of our equations in it. Okay, we've got center, we've got radius, we've got the equations for tangent, all that stuff, okay? We've got all the right formulas and equations in our log tables, page 19 this time. And exam questions normally combine a circle with the line, so we need to really be able to use all our formulas next. However, the center and the radius of the circle are always going to be our most important things to understand, okay? So let's look at this. I want you to give this one a go, okay? The circle here has the equation x plus 2 squared plus y minus 3 squared equals 100. Write down the coordinates of A, the center of C, and write down R, the radius of C, okay? So I want you to do that first question and text me what you think A is and text me what you think R is, okay? And if you don't understand this, don't worry at all. I'm going to be going through just how to do it, okay? Okay, so I'm just going to give you a minute or so on that, guys. Really good, getting some good answers in. Yeah, brilliant. Some good answers in. It's important to realize, guys, we're going to take the negative of these numbers beside x and y. So I'm going to go through that as an example, okay? Our equation for finding out the center and radius of a circle is x minus a squared plus y minus b squared equals r squared. Okay, so what does this mean? Minus a equals plus 2. So a equals minus 2. Minus b equals minus 3. So b equals plus 3. So our point ends up being minus 2, 3. And if we know that 100 squared, 100 is r squared, well then r is just 10. Okay? And I'll go through the next one as an example, guys, just so I can get you guys doing some more questions. The next question reads, write down the equation of the circle, which has center 2 minus 3 and radius 4. Well, that's really simple, guys. We can say we've got x minus 2 squared. Notice how I'm going to the negative. Plus y plus 3 squared. And that all equals 16. Okay? Really good. See, a lot of people got all those answers right. So really, really good work, okay? Now, a wee bit harder, but remember, we've got all these equations with us. I want you to give this one a go. The circle has the equation x minus 3 squared plus y minus 2 squared equals 34. Write down the center and the radius of the circle. Remember, your calculator can do a lot of heavy lifting, guys, okay? Really good. So, please just text me your answers when you get that one, okay? Okay, really, really good. Super, guys. Keep the answers coming in. Absolutely brilliant. Yeah. Brilliant. Really, really, really good. Okay, so a lot of people are, a few people are saying they don't know how to understand it. That's okay. So, guys, easiest way to understand this is to compare it to our formula, okay? So our formula for a circle tells us a minus a squared plus y minus b squared equals r squared. So look at these two equations beside each other. A is the x-coordinate of my center. So if minus 3 equals minus a, well, a equals 3. So there's my point. Now let's look at minus 2. Well, if minus b equals minus 2, well, b equals plus 2. So our center ends up being 3, 2. Now, if 34 is equal to r squared, let me just clean up a wee bit. if 34 is equal to r squared, well then what does r equal? Well, put really simply, r equals square root 34. Okay, now you can use that in your calculator to find out the decimal, but we're basically just mirroring the equation to what we see, okay? Loads of people got that. Very well done, really good. So we do the square root of a case because in our formula reads that it's all equal to r squared. So if r squared equals 34, we're looking to find out what r is, not r squared. So we're going to square root 34 to find that, okay? Really, really good work, guys. Okay, we're going to try and do one more wee question, okay? Or at least one more wee question. Really good work with that. So here's another one. This is an expansion on this. Peter claims that the point 2, 7 lies on this circle, okay? I'm going to write out this circle. Oh, there's a 2 and, yeah, 3 and 2. So we have, I'm going to zoom in for you now, guys, okay? So we have x minus 3 squared plus y minus 2 squared equals 34. Okay? And Peter claims that the point 27 lies on this circle. So all I want you to do for this one, really, really similar to the line. This is them sort of combining the questions. I want you to substitute the coordinates for the points x and y. So sub in x as 2, sub in y as 7, and that should equal 34. Okay? So let me know if you've managed to get this question, okay? So we're just going to substitute in our values for 2 and 7, okay? And guys, you put in a tremendous effort today. Absolutely phenomenal. I personally really appreciate it. We really appreciate it here. But more than ever, you guys should know that this effort is going to go a long way in making sure that you get the grades that you want. All this little bits of work, all this little bit of studying are absolutely worth it, okay? I remember being in your position, a little bit of studying here and there really gets you to where you want to be, okay? Yeah, so we're just substituting in these values, guys. I'm going to go through this really quickly, okay? So all we do is substitute in x as 2. So we're going to get 2 minus 3 squared, and we're going to add that to 7 minus 2 squared. Notice how all I'm doing is taking my x coordinates and substituting them in, taking my y coordinates and substituting that in. And what I want to show is that this side is equal to 34. Well, let's see if that's correct. So I get minus 1 squared in my first bracket, which is the same as 1 squared, which is just 1. And then I get 7 minus 2 squared, so 5 squared. So I'm going to add on 49. And that gives me 34. Now you might look at this and think 50 equals 34. Something's not right here. And you'll be absolutely correct. So this point is not on the line, okay? Really good work, guys. Really, really good work. So that's what we do. We just substitute that in, okay? Oh, someone's asked where the 49 was from. I can just go back and show you. So guys, the 49. Oh, sorry, I've got that wrong. You're absolutely right. It's actually 5 squared. You're absolutely right. I've got that wrong. Someone's paying good attention there. That ends up being 25. You're absolutely correct, guys. That's how important it is to pay attention to your silly mistakes and have good exam technique. Yeah, well done for catching that. That was definitely on purpose. Really good work, guys. So yeah, it ends up being 26, which is still not equal to 34. So the answer is the same, but my math was a wee bit incorrect. Really good work, guys.
Someone's had their Weetabix this morning, Tom.
No problem. TJ's going to come on and speak to us now, guys.
Perfect. I'll unshow you, Tom. All right. Well done, everybody. The last day of the Easter course. I'll spotlight myself there. So last day of the Easter course. Well done. Come here, and I have 2 or 3 questions just to hit you before we give you the test. All right. So Emil, I just want to put up the first little poll and just give us a sense of I want you a sense of what yeah.
You'll have to put it up yourself because we're
yeah,
on the same account, so it won't let me.
Okay. First ones I'm gonna launch. Do you find the lesson? Yeah, I'll go for this one. We'll go for this one. Start. Stick up that little poll there. How'd you find that, guys? How'd you find that lesson?